Okay. So, of course, it's the 27th of October today, so network automation is the topic for the day, but of course, no practical component for that. It's all conceptual. So we're going to look at the trial practical, or a demo practical test for today. And then, of course, next week is testing, joy of joys. Anyway, so we'll run the test 12 till 2 for the practical, for the testing next week. Okay, so of course we're going to do a bit of a demo here today. So I've got a bit of a setup here. So we've got this central HQ router for Flinders, basically. And so we've got two servers that we want to make visible to the outside world. So internal as well as www.flinders.edu.au. There's also a LAN for clients hanging off of HQ. We've got the link to the ISP. So we've got public addressing there, private addressing all through here. And we've got WAN links to branch 1 and branch 2. So the network is set up internally at least. So if we go show IP route, I've actually got RIP working just because I can. And so if you look at the subnets, the server subnet here is 172.16.1. Then we've got the local LAN, which is .2. Now the LANs for branch 1 and 2 are 3 and 4. They've been learnt through RIP. And the WAN links are 172.16.255 and 254. So they're also directly connected. And 204 is the link from the ISP to our machine here. And so that is, of course, on serial 020. And I've also put in a default route, which aims at the ISP router over there. And so, of course, that's the gateway of last resort. So the internal network is working perfectly, but you can't actually successfully communicate with the outside world at the moment. So again, if we look at branch 2, that's working as well. It's got show IP route. And so, of course, it's learnt 1, 2 and 3 from HQ. It's learnt 1 and 2 from HQ, 3 from branch 1, and then it's got directly connected 4, of course, and also the WAN link. And yeah, it's learnt the default route through RIP, so RIP has advertised it, and so the gateway last resort line is there. Now, I'll ping all the hosts that are on the network. So if I ping 172.16.1.10. That's one of the servers. Might have an ART request or two that's required, but it should eventually talk. All good. The other server is .11. Again, probably an ART request involved. But working. The HQ LAN, the host is 2.10. Also working. And of course, the other branch is 3.10. So of course, this machine here is 4.10. So not much point pinging that. I think it should be able to talk to itself. Now, the outside one is basically that server is 205.00.10. So I'll try pinging that as well. This is the one that should fail. 205.0.0.10. That is the correct address, isn't it? Yes. And this won't succeed. Now, HQ has enough information, but the ISP doesn't. Now, of course, so that's not going to work. So, of course, all of the addressing for flinders.edu.au, of course, is all private addressing, isn't it? And so this is a public address and that's a public address. Now, if we look at the ISP router, it actually does not have any information at all. So show IP route. It will only have 204 and 205. They're the two subnets that are active on it. So that's why the ping didn't succeed. It actually, the ping would have gotten all the way to the host, but when it came back, the ISP would have gone, I don't know how to find 172.16.4.10. And so it would have been the ISP router that dropped it on the way back. Now, I suppose we could put in some routing information here. That would fix it. Yeah. But that's not, this is private addressing while this is public. That's not what you do. You don't route using private addressing. And so NAT will fix the problem. So basically the demo we're doing here is going to have NAT, ACLs and management are the three sort of topics involved. And so with NAT, we need to configure dynamic PAT for all internal hosts using the address from S020 as the inside global address. And so we just have to get NAT working with overload to get that to work. And then there's a couple of other static NATs we need to do. So configure static NAT for server www.flinders.edu. And so we're going to use the inside global address of 204.0.0.5 because it's on the same subnet there, so it'll find it. And then we also need to do port forwarding. And so the Flinders one, this is the one that's supposed to be visible to the world. This one is selectively, this int, short for internal. And so I'm just making one port available to the rest of the world. So port 80, web server. And so basically we should have a mapping that will get us to that. And so of course that's port forwarding. So let's have a look at our solution. So of course the first thing you've got to do with NAT is of course on all the interfaces that are active, orient them either inside or outside. Of course, you normally only ever have one outside interface. So of course, that's this one here, S020. So that's IP NAT outside. All the other interfaces, of course, are inside, part of the Flinders network. This is the link to the rest of the world. So that's all cool. Now, of course, for dynamic NAT to happen, the first thing you need to do is define which internal hosts are allowed to have a NAT translation. And so as you can see, I've done 172.16.0.0 with a wildcard mask that only needs to match the first two octets. So any address that starts with 172.16 will match this ACL. And of course, that's what all the addressing on the inside does match. So that's cool. So the last two octets can be anything, don't care. So that's the first thing. Then, of course, we need to specify the inside global address. So, of course, that's the one that's on interface S020. And so here, this is the line that ties it all together. IP NAT inside source list 1, because it's access list 1. Interface S020. So that's the public IP address that the ISP has given us. And of course, overload makes it PAT instead of NAT. So that will get it so that host can now ping that outside server as opposed to the current situation where it can't. Now, of course, we've also been asked to make a couple of static NAT mappings or translations. And so IP NAT inside source static. And so then 172.16.111 is this server here, which is www, and 204.0.0.5 is the address that's supposed to be used on the outside. Again, a member of this subnet. And then here, for our port forwarding, IP NAT inside source static. Now, because we're doing just a single port, you need to specify which protocol. And so, of course, port 80 is TCP. And so we do TCP, the inside local address. So, of course, that's this server here, port 80. And so basically, if someone browses to this IP address with a destination port of port 80, the router will then forward it on to this internal address on port 80. So that's basically what that translation does. So that these configuration commands here satisfy those three requirements. So I've already done the pinging. We know what we can and can't connect to. So let's apply this. We'll go here. Oh, damn. Let's paste that again. There we go. I've forgotten about the password I'd set on there. And so I don't see any errors. The insides and outsides are all working. No errors on those lines. All right, let's do some testing, see if it works. So this one here, we tried to ping outside before, failed. Now we succeed. Isn't that nice? And so we can also hopefully use the browser to get out too. So we'll just and www.cisco.com, of course, is that server there. Now I think I do have DNS set up, so I can actually do www.cisco.com, and that should work as well. And it does, so that's all very nice. Now, so we can do it from the inside goes out now, all successful. We need to test that we've got our statics working. So, oh no, I won't do it from there. I'll copy it from there. Copy. Web browser. Now that is that static mapping, that one-to-one relationship. So it's www.flinders.edu.au. That looks good. Now we'll do that port forwarding as well. So 2, and as you can see, it's gone to the internal.
That 2 is the interface of that HQ router.
Yes, it is.
That's facing the ISP.
Yeah. Yeah. Because I've only translated that port number, yeah. Any other port I connect to will actually try to talk to the router, but port 80, because of that translation, it will send it off to the server. Yeah, so that's all good. I suppose we could look at SHI-PNAT trans. We can see what mappings we've got. So we got the static mapping for the www server, that's just one-on-one. We've got the port forwarding one here for the internal server, and then we've got from that host when I did the web browsing out, this is the connection we got. So it used ports 1025 and 1026 to connect to it. And then these are the ones that actually came inbound from the server. And so to that port forwarding one here, and of course that is the static. So that's all working quite nicely. The ICMPs that I did time out pretty quickly, so because they're not TCP, it's not really a trackable transaction. All right, so what's next? So we've got ACLs. So what's required of that? We need to configure an extended ACL that blocks PCs from branch 1, so hosts here, from reaching branch 2 LAN. So hosts from this LAN should not be able to connect to hosts on that LAN. It should allow all other traffic, and you need to place the ACL in the most efficient interface. So what solution have I come up with? Right, this is where we need a bit of... So this is my solution. Now it said an extended ACL, so that's why I've done 100. And so we need to block all traffic from this subnet. And so I'm denying IP, all traffic IP. And so with this wildcard mask, first 3 octets must match. So source address needs to be 172.16.3. anything. And then the destination address needs to be, again, same wildcard mask, 172.16.4. anything. So that will block the traffic from getting to the branch 2 LAN. But of course, it said all other traffic is allowed. And so we need that IP any. Now, where to place it efficiently? So basically there's 6 places you could place it. There, or there, or there, or there, or there, or there. Now, because we're trying to block traffic from going from there to there, the most efficient place would be here. It's an extended ACL, so it's very specific. And so that's the solution that I've used. And so, interface G000, inbound. And so IP access group 100 inbound is how we apply that. So I suppose the first thing we should do is, before we apply it, see that it does work. 4.10 works a treat. Of course, the plan is that we need to block that but allow all other traffic. So I'll open up this router. Apply the config. And so, of course, ACL lines often go over the line. So I don't see any errors. So let's have a look at this host again. Up arrow, I should get an ICMP message back from my router, and I do. So that's working as it should, but of course we should also test that I can talk to other hosts, because I'm supposed to be able to talk to any other traffic. So blocking works. Does the permitting work? And it does. That's the HQ LAN. Okay, server, that's working. And I suppose we can ping outside as well. 205.0.0.10. That's working as well. So all other traffic works, but that particular traffic in the requirements doesn't. So that's the way we want it. Now there's another ACL we need to write. Configure a standard ACL that will only allow host 172.16.210. So it's this host on the HQ LAN to connect to a HQ for remote administration. So using Telnet or SSH. So I suppose the first test could be, let's try and connect that HQ with another host that eventually will be blocked. So it should work at the moment. So 172.16.1.1. No typos. Looks like it's working. So Cisco should be the password. I'm into HQ. So that's all good. So show IP route. All looking good. All right. So we'll exit now. Let's see how we go with that ACL. Now, as it said, configure a standard ACL. So I'm doing access list 10. I can't use access list 1 because I've already used it. So 10, it's an easy number to type. So permit host 172.16.210. So that's instead of course, supplying a wildcard mask of 32 zeros. Same end result, but of course, at least host is a little more explanatory. And so we're permitting that. Of course, there is that implied deny any. And so that is the only host that should be able to connect to that router. Now, how do we apply it? Now, of course, we apply it to the VTY lines. And that's why we only need a standard access control list, because we're applying it as close as possible to the destination anyway. Now, of course, normally you use IP access group on an interface to run it. Because it's on the VTYs, we need to do access class. Don't ask me why, that's the way they do it. And so 10, of course, refers us back to that, and of course inbound. And so now you've got to be careful with this access class, because that's IPv4, you just do access class. For IPv6, you do IPv6 access class. So if you do IP access class, because there's no other option, it will abbreviate, that will assume that's an abbreviation of IPv6. So you've got to be very careful with it. So if you do IP access class 10, it will actually apply that to IPv6. So you've got to just do access class. Anyway, it would become obvious if you looked at the config, because the config of course doesn't abbreviate it. It would actually show IPv6, but yeah, you just got to be careful. And so of course inbound to the VTY lines. Now the beauty of this is, yes, I'm going to stop people who shouldn't be configuring my HQ router, but it's actually not going to block Telnet or SSH traffic going to the outside world and doing whatever it is. It's only applying it to the HQ router. So it's a very tidy little setup, actually. As I said, as long as you remember the strangeness of the access class thing. So I already telnetted in with another host. So let's apply this and see if it meets our needs. Again, I don't see any errors. You can always do show run just to see how everything's gone in. This is the busy router though. And so you can see all the IP NAT insides and outsides. The router RIP configuration, all of our IP NAT commands, default route. And so you can see access list 1 for NAT, and then access list 10, of course, is what we did for the VTYs. And so you can see the access class 10 there against the VTYs. All right, so let's test that. Let's use this host that shouldn't be able to connect. So telnet 172.16.1.1, connect, and it should reject, and it has. All right, let's make sure that this one can. (172.16.1.1). No typos, and so it's letting us in. All right, so what we could do also is show access list, maybe because I'm not in. Show access there. It was because I was in user exec mode.
Yeah, right. I didn't know it does that.
Yeah, only you can only get certain commands. So yeah, I suppose with access lists I should have assumed it wasn't available. So for access list 1, we've had 20 matches for all our browsing that we've done, of course. And so here we've had matches here, so 2 matches apparently. So yeah, we can see how often they've been working. So all good. All right, so that's ACL's done. That's 2/3 done. Management. Now, the first thing there is turn off CDP on the HQ router. Why would we do that?
Good.
Yeah. More information?
Yeah. So we don't have to price for everyone.
Yeah, basically. Makes it a bit harder for people to find stuff. So, of course, the HQ router is the one that's directly connected to the internet. So it's probably the first one you should do. In reality, you probably should be blocking all of the devices, but yeah, I'm just doing it on the one just so that I can test it. You know what you're doing. Also, so how do we do that? No CDP run, and that will turn it off. So before we do it, I suppose we could do show Cdp Neighbors. And so because it's central to a lot of things, it's got a lot of connected devices. So it's got the HQ LAN switch, HQ server switch, and then branch 1 and 2 routers. and we've also got the ISP router. So we've got a few devices there. And so if we do that in detail, we get all the addresses as well. So, you know, we know the IP address of the switch now, the HQ LAN switch, HQ server switch, branch 2's router, branch 1's router, and the ISP router. So that's a lot of information. So let's go to that, copy, paste. Nothing from that. All right. So what's the next thing? So set up all routers to use internal Flinders edu.au as the NTP time server. So what we need to do here is just make sure that NTP is running. It is. Now, for some reason, I think you'll notice I actually started making this on Friday. So that's the date it's stuck to. So yeah, it sort of gives away when I did this. And so we need to set it to the 27th, and let's set the time back to roughly 12:30. That'll do. So that's good. The time server's ready. How do we do it on the routers? And so NTP server of that address, which of course is the internal one. NTP update calendar, I think basically just speeds up the synchronization of the clocks. Then the next thing is actually set up all routers to use the same server again as their syslog server. So let's have a look at this. Services syslog, it's running. So that's all cool. So how do we do that? So that's the IP address of the same host. So it's now our logging host. Oh, sorry, I missed the end of the sentence. Syslog server with timestamps. So not very useful without timestamps. And so, of course, we throw that in there as well to turn on the timestamps. We set our trap level on packet tracer. That's the only option. And then, of course, we actually need to turn this logging on, otherwise nothing's going to happen. So that will get both of those things done. Copy. Paste. And you'll notice that the messages now have a timestamp. So it's added because it hasn't synchronized the clock yet. So it's March the 1st. Probably 1993, if I remember correctly. But anyway, give it a bit of time. So HQ, same thing on the other routers. Let's do show clock. Yeah, March the 1st, 1993. Give a little bit of time, it will synchronise. So now we should have some messages on that, and we do. Have a look at that. Sadly, it's a bad date, but I suppose what we could do, we have timers. Time is at our mercy. Let's do show clock now. That's a better time. So conf t int g000 shut no shut and let's have a look at that syslog now. So some 2021 messages. So that's of course some use now. Okay. So we've done syslog and time, all good. Now the last thing there is back up all your router running configs to internal flinders.edu.au. So that is actually implying TFTP typically. Doesn't have to be, but so basically these are all the files that are on the TFTP server. When we do this command, so it's just copy running config to TFTP. So 172.16.1.10, and of course it's called HQ config. Here, we'll do it. Branch 2 config. Branch 1 config. All right, let's have a look at the server. Now, we might have to browse out and then browse in again, and you can see branch 1, branch 2 and HQ configs are on there. So, yeah, winning. So that's basically all there is to what the prac test will cover, just those major 3 topics. I didn't talk about troubleshooting. I think I might have hinted last week that I'll probably have a separate topology down below with a fault or 2 in it, and I'll get you to fix that. So just so that the top major topology doesn't get stuffed around with problems. So yeah, so that would be a merit section 1. So
this would be
that would be very equivalent to what the pass would be, is what we've just gone through here. So does that seem like an achievable thing? It's not tough. The NAT and the ACLs are probably the hardest bit to get your head around. Bit of practice for that. I have activated the packet tracer tests on Cisco. They are available for you to use. I will reactivate the practice theory exam. It was active last week, but I can only do it a week at a time. So I think it just expired as we started here today. So I'll re-enable that before I leave today. The feedback survey is active, so if you want to get ahead with that, you can. Yeah. So that's one less thing you need to worry about next week. So for you guys, I'm assuming 12 till 2 will be the time for you. And so same format as you've done other times for testing, theory test, then the prac test. I'm going to say if you know what you're doing with this, you could do this in half an hour easy.
With the troubleshooting, does it only also include this topic? Or is it troubleshooting for the OSPF and everything?
No, it would be pretty much anything that you've done. But I'll give you a bit of a hint what the problem is. It might be a little bit vague, but it will be a hint, you know, like, you know, the host can't ping such and such or whatever it might be, you know. It'll be something that a user would probably report saying, oh, I can't connect to XYZ or whatever it might be. So, yeah, that would be the plan. That would only be one merit point. The other merit point would be some extension to that, I'd say. But. Okay, so, yeah, so the test will be, it'll be the sitting from 10 till 12, the 12 till 2, and then will be an online one from 5 until 7 on WebEx. So I will put out a message with that information. I will create a trial prac test. It's partly made, but so it should be released either today or tomorrow, and that's when I'll put out the message for next week. It'll also tell you that the trial prac test is available and where it is.
Which is going to be this one, isn't it?
Well, no, this is my demo. The trial one that I'll put out either today or tomorrow will be a little more like what the real one will be, in that it'll have the, it will have the separate window with the instructions, and it'll be, like you've done with other previous prac tests.